This is part 2 of the test review for Accelerated Geometry Advanced Algebra. And when we left off, we were working on solving with the quadratic formula. The first thing we have to do is put the terms in standard form. And this one again is not in standard form, so we have to add 10x to both sides. Remember, you can only add if it's like terms. Since they're not like terms, we're going to have 3 terms here. 3x squared plus 10x plus 8 equals 0. Identify A, B, and C. A equals 3, B equals 10, and C equals 8. Many of you like to do this in your head and not write these down. However, if you don't write them down, what happens sometimes is if you have a negative term, you forget the negative, and that will throw off your whole problem. So it's a good idea to write down A, B, and C. So in this case, we have negative 10 plus or minus square root of 10 squared minus 4 times 3 times 8 divided by 2 times 3. Solving that, we'll get negative 10 plus or minus the square root of 100. 8 times 3 is 24. 4 of those is 4 less than 100, so it'll be 96. Divided by 6. So we get negative 10 plus or minus square root of 4 divided by 6. And again, we can take the square root of 4 since it's a perfect square. Plus or minus 2 all over 6 will give us negative 10 plus 2 is going to give me negative 8 over 6, which reduces to negative 4/3. And negative 10 minus 2 will give me negative 12 over 6. And so I'll just have a negative 2. So my solutions are negative 4/3 and negative 2. The next section is talking about the discriminant. Remember that when we find the discriminant, the only thing we have to do is what is under the radical in the quadratic formula. So we're only going to work with b squared minus 4ac. We want to know how many roots and are they real or imaginary. If d is greater than 0, if the discriminant is greater than 0, we have 2 real roots. If d is equal to 0, we have 1 real root. And if d is less than 0, we have 2 imaginary roots. And remember, root and solution and zeros are all the same thing. So our first problem, we have negative 7x squared minus 9x minus 19 equal negative 9. Still working with the quadratic formula, you still have to have this in standard form. So we're going to add 9 to both sides. This time I do have like terms. So my result will be negative 7x squared minus 9x minus 10 equals 0. So now A is going to be negative 7, B is negative 9, and C is negative 10. So negative 9 squared Remember that you're squaring the -9, not the 9, because b is -9, not 9. -4 times a is -7, and c is -10. So then I get 81 minus, I have 3 negatives, it's going to result in a negative. So 28 times 10, 280. Negative 199. Negative 199 for my discriminant. If I go back over here, that is less than 0, so I have 2 imaginary roots. The next one is negative 9p squared plus 3p plus 2 equals 3. I need to put it in standard form, so I need to subtract 3. So I have negative 9p squared plus 3p minus 1 equals 0. Negative 9 for A, 3 for B, negative 1 for C. So I'll have 3 squared minus 4 times negative 9 times negative 1. Again, I'm going to end up with a negative here. So I'm going to have 9 minus 36, which will give me negative 27. Again, 2 imaginary roots. Right? Number 7, 9a squared minus 6a plus 18 equals 9. Subtracting 9, I get 9a squared minus 6a plus 9 equals 0. So I have a equals 9, b equals negative 6, and c equals 9. So I have negative 6 squared (4 times 9 times 9), 36.
Coach Reeves, if you're still in the building, could you please come to the front office? Coach Reeves?
I always wonder about that when they say, if you're still in the building. If you're not still in the building, then you're probably not going to respond to that. Okay, let's just...
Kyle Kreiser, if you are still in the building, please come to the front office. Kyle Kreiser?
9 times 9 is 81 times 4 is negative 324 equals negative 288. And again, we have 2 imaginary roots. Number 8. K squared minus 6k plus 16 equals 7. And A is 1, B is negative 6, and I need to subtract 7 from both sides. which will give me 9 for C. And I have 36 minus, look at that, 36 equals 0. So I have one real root.